Okay, hi everyone. Thank you for being here. We've got a group of people here in person, and I see several people coming in to the Zoom. So thank you all for joining us. My name is Ashley Griswa, and I am a co-chair of the Committee on the Environment this year. And we're very excited today. Oh, first we want to start by thanking our sponsors, Lake Plato, Hill and Wilkinson, and Pilgrim Building Company. We really could not put on these events and do the programming that we do without their support, so we really appreciate that. And today we're really excited to have a great conversation for you all that's part of our health and wellness kind of subcommittee. So Kate Bren from Positive Energy is here to kind of introduce our speakers and kick us off.
Hi, everybody. Again, welcome. Thanks, Ashley. Part of my job at Positive Energy that I get to do that I think is really cool is just talk about building science and why high-performing buildings are something that the broader public should know about. And that's something that both Nora and Gayle have been doing for decades. So not only are they doing that, but they're also helping do it with people who can benefit from the high-performance buildings the most and benefit from that indoor air quality the most. So without further ado, I'll introduce them. And I'm a millennial, so I'll be using my phone. Noralinda Ureste is the owner-developer at Flourish Here Retreat, which are vacation rentals for chemically sensitive travelers. She's motivated by her mother's MCS condition and has spent half her life trying to understand what makes an indoor space safe and healthy. Her background in building biology, building science, healthy building materials, interior design, and environmental toxins have led her to unique and forward-looking approaches in placemaking. She's a wife, mom, and citizen building scientist who enjoys watching the fluctuations of her indoor air quality monitor. Gayle Borst has been a stubborn optimist for the role of natural building materials in the architecture world for more than 3 decades. She founded the architectural design and consulting firm Stewardship Inc. in 1992, where she combined her love of efficient, high-performing, human-centered building with her passion for healthy, natural, environmentally responsible building practices. Gayle co-founded Design Build Live, which is a nonprofit dedicated to teaching others about healthy and natural building. She has degrees in biology, chemistry, and energy studies in architecture. Through the years, she's played many roles in our Austin community, including as a lead consultant, Austin Energy Green Building Advisor, sustainable building advocate, and community mentor and earth protector. Go ahead.
Oops, that's not touch screen.
While Nora's pulling that up, I just want to say it's been an honor and a privilege to work with Nora. I mean, I've had some pretty educated clients through the years, but she takes the cake. She really knows a lot. So this has been such a team effort with Nora very much driving this. So, and she's going to be driving most of this presentation today, but I'm kind of here to act as the architect liaison. So since most of you are probably architects, and I can maybe bridge a little bit of that for y'all. And I will say it's difficult to talk just about the healthy aspects of this project because it is very much a holistic project that we consider a lot of other aspects that we'll be talking about. But anyway, and if we're a little rough around the edges with our presentation, forgive us. We've both been out of town, and so we'll see how flawlessly we can switch, but we'll give it a try.
Thanks, Gayle. Okay. Okay, thank you. Oops. This might not. Trying to advance. There we go. Okay. All right. Thanks, Gayle. Thanks, Ashley. Thank you, Kate. I just kind of wanted to briefly kind of go over what we're going to review today. I'm going to talk about the motivation and the opportunity that
we saw when we wanted to embark on this project. We want to talk about enclosure strategies to mitigate building failures, and then also to maintain the indoor air quality, really the environmental quality of the spaces. And then we're going to describe how building with natural materials reduces chemical exposures and improves human health. And then we're going to talk about strategies for creating an indoor air quality redundancy with robust mechanicals. And then finally, strategies for reducing chemical exposures from water and promoting human health. And so I had a question for everybody today. Have you ever experienced allergies to pollen or dust? Have you ever experienced watery eyes or itchy skin after using a cleaner, a solvent, a soap maybe? Very common, very common. But if you can imagine, there are some people that have severe reactions to indoor and outdoor pollutants, like fainting, like nausea, like migraines that last, days, like crippling fatigue and brain fog when they're exposed to these indoor and outdoor pollutants that are common in our homes, in our schools, in our grocery stores, in the hotels that we visit. They're fairly common. And so,
let me just add a little bit here. And these chemically sensitive people, they're not flawed individuals. They just suddenly kind of hit that tipping point, which every one of us could do. There's just kind of no predicting. So this, even though some of the things that Nora and I did on this might seem extreme, I think everybody can take something from it. And you may not be able to take it to that degree, but the more we can reduce the toxin load, the better, and help all of us not to hit that tipping point.
Definitely. And so the inspiration for the project that we're about to break ground on next week, I believe, week after maybe, a set of vacation rentals for people that are environmentally sensitive, environmentally or chemically intolerant. And so basically my mom, I want to tell you the story about my mom. She's kind of the inspiration for this project. She was exposed to fresh paint in her office when she was working at UT Edinburgh in the Valley, in the Rio Grande Valley. And at that time, there wasn't any kind of awareness around chemical sensitivities. But also my mom in her home, she had mold growing in her vents that led her to be immune compromised that she didn't really realize. And so after the exposure to this big exposure to fresh paint, she became really ill to the point that she had a hard time getting out of bed for about a year. Her home was remediated. She basic avoidance of chemicals, but leaving her home and traveling was almost impossible. And so this happened, oh gosh, it was about 25 years ago. So it's been a while. Fast forward to 2017, my husband and I were running an Airbnb in Terrytown, and we decided we wanted to create safe spaces for people like my mom that have a really hard time traveling. And so that led me to study building biology and building science and toxins. And I discovered that there are a lot of people like my mom through Facebook groups and just talking to other people and the courses I took. And yeah, she wasn't obviously the only person. And actually, I'll show you. Oops. I wanted to say say that there's a sample, a study done by Dr. Miller out of UT San Antonio. They did a sample survey of 10,000 residents, and 1 in 5 found overall basic chemical intolerance. Basically, the population, 20% of our population is chemically intolerant based on the 10,000 resident survey that they did. And what causes it? Let's go back one slide. How do I go back a slide? Oh, there we go. And so nobody really knows what causes it. It's very complex. It's a combination of your own genetics, of your exposures throughout your lifetime, whether it be long-term exposures or acute exposures, but it's also your lifestyle. And so there's many kind of health drivers around this chemical intolerance condition. At the same time, I discovered that globally there are 350,000 chemicals and mixtures registered on the global market. Kind of crazy. And then there was another study done in 2021 that found 55 chemicals of concern in building materials. That's in our homes, So I found that to be just mind-blowing. And you're probably wondering, but doesn't the EPA regulate all these registered chemicals? The truth is that where is it? Oh. Toxic Substances Control Act does not require companies to prove the safety of chemicals they put on the market prior to putting them on the market. 80% of all new chemicals are approved in 3 weeks by the EPA. So far, the EPA has only required safety testing for 200 chemicals out of the 84,000 chemicals that are registered in the United States, and only 9 chemicals have been banned by the EPA out of 84,000 chemicals that are registered in the United States. That is like 0.0001% of all chemicals. Possible side effects of these chemicals are they're an irritant. They are endocrine disruptors. They lead to cardiovascular disease and metabolic disease. They lead to learning and behavior disorders, mostly in children. They disrupt your immunity. Essentially, the body becomes chronically inflamed and can lead to autoimmune conditions. Those are the health effects. When you look at the environmental effects, studies also show that there's lots of pollution that happens to our air, to our water, to our soil from the manufacturing of these chemicals. And they contaminate our food and our water supply. They lead to climate change, ecology disruption, and they disproportionately affect marginalized communities, low-income workers, people of color, and children. So the opportunity here, after discovering how ecological and human health are intrinsically linked, and learning how little oversight there is over the chemicals that go to market, and then kind of understanding, after looking at building science, common design practices that can be risky for human health, and then discovering how our building materials and our tap water can be a source for chemical exposure. And then finally learning that budget and schedule are put many times before occupant health. And so with that motivation, Gayle and I had the opportunity to use the precautionary principle to make choices in design and building material selection and our mechanicals, and the potable water that we want to supply to the vacation rentals to create an environment that would act as an intervention for health, not just for people that are chemically intolerant, but also for children and anybody else that is seeking wellness. So yeah. And so I want to list the opportunities and strategies. We looked at lots of stuff. We looked at the materials, we looked at the design, we looked at the mechanicals, and we looked at the water that we're going to be providing for the occupants. And we came up with a long list of things. I won't go through all of these. We're going to go through most of them in the slides. But you know, we started here, and not to say this is an exhaustive list either, because not only is the building important, how it's constructed, and how you manage it, but we also understand that, you know, a healthy space also includes the things that you bring into it, the habits that you keep while you're living there, the maintenance that must occur so that your building doesn't fail, so that you catch you know, a leak or a repair that needs to be done quickly so that your building doesn't fall into disrepair. So kind of with all of that in mind, go ahead. Do you want to say something, Gayle? Sorry.
Okay, so I'll just talk very briefly about the materials and design. We're going to get into these in a little bit more depth, and then Nora will talk about mechanicals and water. But this was a very materials-driven project, and not only from the health aspects, but Nora has high standards in every ways. And as you can see, we wanted to do red list free and things that were recyclable and could go back to the earth, and not impactful, and an emphasis on both local materials and local labor as well, and natural, which is one of the reasons that she came to me. That I've been doing natural building for some time, and that's one of the easiest ways if you're looking for a non-toxic building is to aim for natural materials. And then on the design end, again, we've got another slide that'll show a little bit more, but one of her requirements was for vapor open envelope, and a lot of the driving force there was no mold. This building cannot have mold, period. So we're looking at vapor open walls, floors, ceiling, and must not do mold. Yes.
I saw that, and maybe this is not the time to ask, but this is the professional group. I find vapor openness a cause of mold because you have the ability of warm, humid air to find a cold condensing surface inside. So I'd like us to talk about that when it's appropriate.
Okay, good. Yeah, and just the short answer is we can avoid those cold condensing surfaces, definitely, because it can vapor diffusion can happen. So, and this building is also going to have a really superbly designed HVAC system with humidity control as well, which definitely helps. So, but yeah, we can talk more for sure. And then another one of Nora's big requirements is that it be.
Do you want to move to the list? You can.
Okay. Yeah, I'll go through them quickly.
Oh, sorry. Where were you?
Okay, so yeah, so that it be easy to service. So that impacted the design in many ways. No attic space and real ease of access to maintain equipment. Definitely easy to clean and maintain because Nora's going to be, she's on site and going to be taking care of this. Appropriate site drainage, we'll talk some more about that, but she employed a permaculture specialist. We're dealing with the water all the way from the site down to the details of the building. Let's see, open buildings, and yeah, space for the mechanicals.
Just you. This is just kind of where we started. This was very collaborative between Gayle and I as our wish list around design and the materials. And we started with this. Obviously, this evolved. It's probably hard to read.
Right, and it's going to be hard to read, but we just wanted to show you kind of the process we went through. So Nora had lists of her requirements, and we just kept refining that and developing it, and then it eventually turned into the specs, which and not all decisions have been made yet. So we're still working on it. But we just wanted to show you that we went through this process. Do you want to talk about materials?
So material-wise, we were looking for materials that would do several things, you know, that were obviously the number one priority was human health. And so we were looking for benign products that didn't have added chemicals like adhesives or formaldehyde, things like that. But also looking for materials that would serve as an anchor for moisture regulation, so that were hygroscopic. And then that were also circular in that, you know, when the life of this building is done, that it could go back into the earth and not into a landfill. And not every component obviously is like that in this building, but we did consciously select materials so that with that in mind. And then, you know, local materials were really important to us. And same there, we can't get every material locally, but, you know, we are trying to get the most, as much as possible locally.
Okay. To just briefly talk maybe about some of the materials that Nora has highlighted here. She came to me wanting to do hempcrete. And, you know, I knew about hempcrete, but hadn't had the opportunity to do it before. And sign me up, because I've done just about every other natural building wall system. So it's great. There's still some impediments. We need to localize it more, but we're working on it. We've got some good local talent that can formulate it. We're still having to import the hemp herds, but we can get local lime. So that will be all the wall systems on the outside, and we don't have a lot of partition walls, but on the inside, hempcrete as well. And so structurally it's a wood frame with the hempcrete infill. We're doing about 12-inch walls. So the frame is in the middle. We chose to put it in the middle. Sometimes it's to the outside or the inside. We chose to put it to the middle for thermal reasons. And our builder said it's just as easy. So that.
Are you talking about a 2x4 type wall frame that's encapsulated in hempcrete?
Correct.
Why do we need it even? Is the hempcrete not structural?
It is, at this point, it is not. Because it's a lime matrix. So it's not, but we have some really good lime people, and one of them is working on a load-bearing lime. And lime, there used to be lime products. So we're getting there. It's just going to take time. And I believe there's at least one, if not two, block systems that are load-bearing.
They're out of Canada.
Yeah. I mean, Canada and Europe, as usual, are ahead of us, but we'll maybe catch up. So yes, correct.
Do you have PVC plumbing?
I'm sorry?
Do you have PVC plumbing?
We're going to talk about that.
Okay.
Yes.
And this is just an example of some houses here in the United States. There's the first, I guess, hemp house in Washington. They call it the Highland Hemp House, and it was a retrofit. So they, I think it was a 1960s house that they retrofitted in 2019 with hemp lime, hempcrete construction or insulation. And then the one below that is just to show like the beauty of plaster and what it can look like. This here is a kit house that you can purchase. It's insulated with hempcrete. I believe it's a timber structure, and then plastered with lime plaster.
And I believe Nora put out a photograph on the back table of the Minka house, which is it's an antique Japanese timber frame that was imported from Japan and is being infilled with hempcrete. If any of you all follow Matt Reisinger's Build Show, he featured this project, and it is gorgeous. So there's hempcrete walls, and they've done earthen plasters on the inside, lime plasters on the outside, which is our intention here, and it's exquisite. It's really beautiful, and this will be too.
And then I'll kind of hand it over to you, Gayle, to talk about the vapor open envelope.
So yeah, and we won't get into it in depth. I'll just talk to Peter offline. But no, sorry, no. We need to talk about this.
Yeah, Peter's
it's just such
concern.
a big issue that it's been around so much.
It is.
I'd love to hear your.
And so our thought was, so I know what you're talking about, humid air coming in, and so I think you're talking about infiltration rather than vapor diffusion. Vapor diffusion, and so
look at today. Great example.
Yeah. Mm-hmm. And luckily, like the materials that we've chosen, the clay and the hempcrete are moisture regulating. So the thought is that they would be the anchor for moisture management. And then when we needed help, our dehumidifier would kick in to help with any kind of additional moisture.
Yeah, how do the walls dry out?
Well, naturally, they'll hang on to the moisture until the relative humidity pulls it out. What
time of the day would that be in the diurnal cycle?
Oh, I don't know if it would necessarily be time of day. It could even be on a wider cycle than that. But I wish we had access to the Moroni experiment. There's some really good, there was a study done kind of informally by John Moroni, who has passed, but he showed how the clay plasters help regulate the indoor humidity. And it's really phenomenal.
I do like that. I'd like to know more about that, but I've never seen one that refers to our hot, humid climate. And that's what I'm most interested in learning about, ones that work in a hot, humid climate have been shown to work in a hot, humid climate.
Yeah, he did. I'm trying to remember what city he was near, but in South Texas. So it was.
Well, that would be close.
Yeah. But yeah, I do want to talk to you some more. But basically, all the materials that we're using are vapor open. We'll be using an intelligent membrane, and a lot of the hempcrete, since it's lime based, again, will be a sink for moisture, but let it go. The clay plaster will absorb much of the humidity, although the mechanical systems do so. It would be interesting to see if we could do this with a non-mechanically ventilated house. And I think if the homeowner is there to regulate, I'm getting way off topic. We should get back. Sorry, we should get back to the health aspects. But if anybody wants to talk to me, Nora will put up our emails at the end. And I love talking about this. Nora loves talking about it. So contact us. So anyway, and the only other quick thing I wanted to mention is that we revised our walls, our wall section to do the monopoly house that Matt Reisinger talks about a lot. I don't think he invented it by any means, but so that we could get a continuous air barrier from roof system to wall system. And I think that's really.
Can I make one quick comment?
Absolutely, please.
So it is my humble opinion that the conversation about vapor open versus vapor closed in most situations is less important than the conversation about air tightness, because in a hot, humid climate, the majority, like 96% on the order of moisture or vapor coming into the home is air transported. It's not transported through vapor diffusion. So you have the mechanical means to dry. So long as your rate of drying is quicker than your rate of wetting, then you're going to be in good shape. It's not really a problem. So and of course, the wall assembly is designed to drain as well. So we're talking about two different things there.
Yes.
So are you saying we're putting too much emphasis on too small a portion of the
year? It's like 4% over the year. We've done a pretty extensive Wolfie modeling on this, and I found that it's neck and neck, with a Lumaflash and or like a Delta dryer or Delta vent, whatever that other is.
So you have done Wolfie studies on it. Yeah. That's what I was going to ask. Have you guys done Wolfie studies on it?
I have not. I
We've
rely
done
on these guys.
some extra modeling on the hempcrete stuff as well. It's a great product. So anyway, I don't want to sidetrack us. Just wanted to throw that in there.
In case y'all didn't know, that was Miguel from Positive Energy.
Oh,
just moving forward, the people on Zoom are using the phone, so they can't really hear those conversations. I repeat, like what the question was before you answer it.
Okay, thank you for that.
Yeah.
Okay.
Okay. So the next really important thing for us was in the design was to make it low maintenance, easy to clean, easy to service, makes for a healthier building. Dust can be really toxic with pollen in it and mold, and also any kind of things that might come off your shoe, like pesticides and all kinds of chemicals you might pick up walking on asphalt or even the sidewalk. So all of that ends up in your dust. And so we wanted to create a design that mitigated for dust collection. So seamless floors, minimal relief on our trim, on our doors, no crevices. We really tried to eliminate hard to reach places that we would not be able to get to inside of the envelope. And then easy to service, meaning that there would be no part of our mechanical system that you would not be able to see to evaluate if it needed service or repair, say like a leaky pipe. We chose not to put any in-wall pipes in our design. We only did through-wall pipes, and so everything resides inside of a mechanical room.
Would you say that again? LED pipes, did you say?
Through-wall pipes. And so the pipes
You're
are.
talking about the plumbing system?
Yeah, the plumbing.
No plumbing in the walls?
There's no plumbing in the walls.
In the perimeter walls.
So what's the idea behind that?
So the thought is that you would be able to see if there was ever a leak. And so there's tons and tons of situations where, you know, there is a slow leak happening inside of a wall. It's not caught for weeks, sometimes months. The inside of the wall is basically deteriorated, but has also affected the health of the people living inside of the home. And so we wanted to eliminate that fear that some people have of plumbing inside of a wall that you could possibly miss maintenance on.
So the drawing on the right is a little bit difficult to read, but that's what it's illustrating. Is that, and it doesn't even show which part is hempcrete. But so like the lower wall would be hempcrete wall, and the upper and right hand wall would all be just open to that mechanical room for service and for observation.
Thank you, Gayle. And then drainage was a huge part of, you know, managing the water, and we took into consideration the site. Our site, you can see basically where all the yellow lines and blue lines, red lines are, those are where the cottages are going to be, and they're away from our dry creeks, and so they're kind of at the highest point of the property that we have, and so water is always going to basically go, I guess in this case, north.
Is that downhill from the house?
Yeah.
Oh,
no, sorry, not
high,
it's uphill from the house.
Yeah.
And
up
so,
on the page is high and down is low.
Oh.
Yeah.
Right. Yeah. Yes.
Yeah.
And they're working with a series of berms and swales to divert water around the cabins rather than
and the house
and down
and the house. So the house is right there in the middle. We'll be living right. We are living there. We are. And so yeah. So protecting the house and protecting the cabins from, you know, big rain. And then if you want to talk about
and then of course we have to look at water as a system. So do what we can on the site to divert rain around, and then fully guttered, and water goes to rainwater cistern, and then we'll have continuous French drains to prevent any water that does percolate or get through or falls on the ground inside the berms and swales. And then just as a precaution, since we're doing an earthen floor, there's a gravel layer to break the capillary action and somewhat serve as a drainage layer, but there really should be no water in there. But we're going to be chicken here because we haven't done we haven't done many earthen floors in this country. And so we're going to put a French drain under or in the gravel layer as well.
Is there a robust vapor barrier still too, or not?
The question is there a robust vapor barrier? This was a huge, well, a big point of contention early on. Since I've done earthen floors without vapor barriers, I'm a big proponent of it. And also Nora's husband wants the connection to the Earth's energies that, according to my research, you don't get when you put plastic in there. So we decided to go, and some consultation. Well, I've been pushing for it for a while, and
So the answer is
very
no, you did not do it.
so no. In that we decided not to, and Nora, doing her due diligence, really waited till we talked to some really knowledgeable people like John Straub, and he reminded us that when in doubt, leave it out. And
But I also think it's site specific.
Yeah.
We
Oh,
probably
absolutely.
wouldn't be able to do
Absolutely.
this, obviously, with
high clay.
Yeah, high clay content.
Maybe.
Like we are
Maybe.
on a limestone bedrock,
Mhm.
and if we weren't, we probably wouldn't. We would do a vapor barrier.
It was I'm only bringing this up because we had this similar situation, house down below, and karst formations and moisture hitting the slab that we didn't count on because it was subterranean. It was all limestone, but there are karst formations in the houses downhill from the grade above. That's why I was bringing it up.
Yeah. We're not going down very far because we're going to hit rock. So we're pretty confident. I mean, if we found anything suspect when we do the excavation, we could reconsider, but I really don't think we
But
have
so
to.
far, you've been living in the house and it's fine?
Yeah. Well,
But,
I mean,
but her house doesn't have an earthen floor.
yeah. This is.
Yeah. And I will say we did an earthen floor off of 45th Street, which is in a high clay area with no vapor barrier, and there have been no moisture problems with that. So I feel quite good, but the conditions are right here.
Yes. And this is just you can see the mechanicals are for IAQ redundancy. So we worked with Positive Energy and to put a specialized, system just for us and for our special guests. It's so important to have clean air and to be able to manage the moisture and to filtrate all that air, because we are in Central Texas and there will be pollen, there will be dust. People will bring in things off of their shoes that will end up in the air. And so this is for redundancy. And we wanted to make sure it was accessible. So like we were talking about earlier, to be able to maintain it while a guest might be staying there without disturbing them. And then just also
Change filters.
yeah.
Do you have the video
Yeah.
of this very complicated looking big system for such a tiny cottage? But hey, that's what it takes.
Walk us through.
Yeah.
Miguel.
Do you mind pointing just with the mouse?
Oh, sure. Yes. Okay. So this here's the water heater, of course. I believe this is
in the back right now.
Yeah, this is the air handler, and this is the ERV for fresh air. This, I believe, goes to the bedroom. These two go to the bedroom. These two ducts go to the bedroom. Yeah, I think.
We did it. We did the dehumidifier underneath.
Yes.
So you did a separate DU in this house, Miguel?
Yep. Always
So-
do that.
In addition to the ERV, or was it part of the ERV?
It's its own unit. So dehumidifiers handling humidity, ERVs handling ventilation.
Okay. And that was purposeful.
Alrighty.
So no accident.
And then I just wanted to talk about rainwater harvesting as a additional means to mitigate chemicals and pollutants in our water. It's fairly, well, maybe it's not fairly common, but it's not uncommon in the Texas Hill Country to harvest your rainwater for potable drinking water. And that's what we use at our house, and we love it. And so that's what we wanted to do for the patient rentals as well. And we chose to do this because basically with the low contaminants, it has no fluoride, no chloramine, which are both neurotoxins. We are going to be storing them in a plastic-free cistern. Through our research, we learned that most cisterns or tanks are either lined with a plastic or lined with some kind of a plastic. And we really want to avoid using plastics because of their endocrine disrupting properties. And then there'll obviously be filtration. We decided to do a ferro cement tank, which has a long life. And then we're processing our gray water and black water with an anaerobic septic system. And that, again, is fairly, it's not uncommon where we live because there is limestone, basically. We're on a bed of limestone. And then dual purpose, it will also eventually be a stargazing pavilion or a yoga platform. So we look forward to making it looking beautiful.
So the ferro cement or ferro concrete cistern, we've been doing these for a long time, and I found that they do crack and leak. So we were lining them on the inside with the expandable parging out of Puerto Rico. I forget what it's called now. Ray, maybe you remember it. Oh, that's true. Yeah. So the two questions are: how are you going to deal with that eventuality? And the other thing is, how's the water taste? Because you've got that acidic taste in the water. How do you do that?
Well, it'll be an alkaline taste.
Yeah,
From yeah.
taste. And so are you putting a charcoal filter in the system?
There will be a neutralizer on the filtration system.
But otherwise, there's no lining of the inside with any kind of parging, nothing?
We're going to be using Zypex on the inside.
So what is that?
Zypex.
It's a crystalline waterproofing system that's parged on. It's not always necessary. For some reason, the contractors, I don't know, and nobody knows why. They had a problem with a crack, and so we're going to be parging the inside. Normally, because it's done as a hard trowel lime finish on the inside, and that serves the purpose. And then early on, you would get more lime coming off of it, but eventually it'll kind of more stabilize.
But it sounds like the same product we're talking
No, Zypex is a cementitious. It's not really an expandable, and it works by crystalline technology that the molecules can move and seal little cracks.
I use the wrong term. It sounds like the same stuff.
It could be. And then we also have learned recently that Zypex also makes a concrete admixture that you can add to make your concrete waterproof, water resistant. So we're going to try. Yay. We're going to try that instead of damp proofing on the top of but the only place we're using concrete is for the stem wall. And then we were going to apply a damp proofing to that. But if we're able, we've had some problems, and we'll talk some more about problems, about we were going to have to do a damp proofing as another step. But if you add that if you add the Zypex admixture, you should not have to do that. So we're learning here. So might this be a good to talk about Peter's earlier question about plumbing piping and connections. We went through quite a study of different plumbing piping, especially for the potable water. So it's going to be all copper on the potable lines, correct?
Yeah.
And we found some connectors that enable us to not have to use solder, because solder still has heavy metals in it. So we're looking at every little bit, and especially when when it's going to be consumed. That's really particular. And
well, and that's inside of the mechanical room that will be copper, but we're doing HDPE, for the supply line coming from the cistern.
Which brand are you doing? High density polyethylene?
Yeah.
So PEX Uponor, or the Uponor line of PEX, you find that's not cool? A really good one?
Well, for inside, or do you mean coming from?
All your fun.
Instead of copper,
all your supply.
for potable water.
Yeah.
Mm-hmm.
I guess we found that HDPE, one, it has a much longer life.
Sure, but it's like PVC.
It is. It is. And so I felt like there can be some leaching with the PEX. And I felt with HDPE, at least at the end of its life, it's recyclable. And I felt really there was no really good solution for pipes.
And all the HDPE is on the downstream side of the treatment. So once the water is treated, then it goes into copper.
So you're actually sucking water, or the treatment?
From the rainwater system
But isn't
into the system.
HDPE like a PVC? Well, I think the specific question is, you found that it was less toxic than Uponor, the really good cross-linked polyethylene. Because they're both polyethylene.
Yes, they are.
You're talking about
What
a
I found
density
is
one versus a super cross-linked one.
I found that plastic is plastic, and it's always going to put something into your water. I felt at the end of its life, the HDPE was a better choice because we could recycle it. Unlike,
how can you recycle it? Is it like?
It's like a milk carton.
Gotcha.
So, and that was it was hard. It was a hard choice. Like we would love to do the whole thing in copper, but it's cost prohibitive for us to do it when we had a central cistern for the whole development.
Answered the question nicely. So once you do the filtering and the disinfecting, then you're going copper.
Yes. So challenges, lots of challenges. Novice, self-building developer trying to work on this. So we've had a lot of hesitation, and I don't have connections like a contractor would. But being in a rural area, and the project being very small, sometimes not only can I not find contractors, but sometimes the materials we want to use aren't available to us. So some quartz products we wanted to use for the sink, our project was too small for them to supply us. Finding concrete that doesn't have chemical additives. It was even hard to find concrete that didn't have fly ash in it. So things like this, because our project is very small.
And nobody's going out of their way to accommodate us on a special concrete order.
Why? What's the problem with fly ash?
Yeah, we talked about that.
The question is, what was the problem with fly ash? I don't know. The concrete companies I called, they're really reluctant to take it out of their.
That's why would you want to take it?
Oh, why would we want to
heavy
take it out?
metals?
Because of the heavy metals in the concrete. And I'm thinking, so yes, for the most part they stay in the concrete. But I guess I'm doing my best to think really long term. And if that foundation was ever demolished or disturbed in some way or needed maintenance, then you're contaminating the ground around you with heavy metals. So this is really, really long-term thinking that I'm sure most people wouldn't consider.
And there won't be any direct skin contact. So it's one of the things that is a preference, but if we had to let go of it, we probably could. But if there was direct skin contact, if it's a concrete floor that wasn't going to, the exposed concrete floor, which we aren't doing, that there would be direct contact, especially with children, then I would say definitely make the efforts to not use fly ash. And it is kind of contrary to, I've been in the green building arena since the early years where we were really pushing concrete floors, it's doing double duty.
Well, it was also the plasticizing effect. But yeah, it's interesting because in the early years we were trying to get higher and higher percentages of fly ash,
right,
to make use of a waste product to reduce building embodied energy and all that stuff.
Yeah. So we're already over.
Yeah,
time,
we are
so
over. So in summary, Gayle and I use the precautionary principle, and we did our best to put health compromised guests first, with the materials that we chose, with the site appropriate design, with the MEPs, with the rainwater capture, and then we wanted to prioritize sustainability with using local natural materials that were circular, that benefits human health. So that's our summary for indoor space as a health intervention.
It didn't make it onto a slide, but we have some resources that maybe you all can work your magic and include with the, and let me do mention one in particular. There's a new book out called Prescriptions for a new edition of an old book, Prescriptions for a Healthy House by Paula Baker Laporte and company. She really knows what she's talking about. And I highly, highly recommend the book. It's very thorough. Like I said, a brand new edition. So please check it out. Prescriptions for a Healthy House. All right, thank you.
Does anybody have any other questions?
Is this a retrofit?
This isn't a retrofit. This is it's a new.
Where is it located?
We're outside of Dripping Springs. So Northwest Hays County.
Is it a county permit requirement or?
Not for the building, but for the development. Yeah.
Does anyone have any questions from the Zoom chat? I haven't seen any come in, but please feel free to drop them in if you have them.
And Ray, a little bit more on the regulatory issues. The fire marshal was definitely on the challenging list. And unfortunately, Nora had to hire a special consultant to tell the fire marshal that we didn't have to do all the things he was asking us to do. But then also in the county, there are advantages. There are things that we can do in the county that we can't do in the city. So, yeah, Ray's laughing. Okay, so yes. And if anybody wants to contact us, please do. If there are any specific things that you want to ask about.
You
Yes,
didn't answer
Peter.
the question about PVC. Did you use PVC for your drain plumbing?
So the question is, did we use PVC? And yes, we did. We used it before, so we had the septic put in. I didn't realize what kind of plumbing they were going to use, and so they did use PVC before we specified the HDP. We kind of jumped the gun with our septic.
Otherwise, in the slab, you used HDPE for your drain plumbing?
We will, yeah, to go to the connection of the septic system.
So you're using HDPE where most people would use PVC for your drainage plumbing.
Right. And so we did try to use no PVC, no vinyl, because of the health and environmental impacts of PVC, how toxic it is.
So you can get a lot of fittings and all that in HDPE?
They will connect to PVC.
But
Yeah,
you can
and
get fittings out of HDPE, like, elbows and joints and all that
Yes,
stuff.
yes. Yes, and it is different types of fusion, like you have to fuse it rather than PVC that's just glued. It's actually fused with a heat kind of machine thing that fuses it together. But for the electrical, there will be, you know, elbows for the electrical that they, I believe, fuse together with the more, because it has more of a flex than PVC would. PVC is so rigid, but HDP is a little bit more flexible.
You got it locally?
I'm sorry?
You sourced it locally?
Yes, I did.
So speaking of,
I'd have to look that up.
Because
I
that's
can't.
a big issue now.
I just remember my guy's name, Eric.
yeah.
But yeah, there is a local source here, and he's really knowledgeable. He's really great to work with. So I'd be happy to make an introduction. He's a good guy.
So, and speaking of sourcing, that definitely is an issue. Like Nora had to order the Gutex insulation from 475.
Yeah.
Which is on the resource list. So that has to be shipped in. So we're violating our local. Of course, most of it's not local. Most insulation is not made locally anyway. But that's a problem with and anybody doing high performance building right now. You realize you've got to import a lot of stuff. We're getting more and more sources in the U.S. like the Gutex insulation. I believe there's a factory coming online next year for a similar product. Am I remembering that right? On the East Coast?
Yes.
Yes, but yeah. So be prepared for long lead times. And the other thing I wanted to mention that Nora was talking about earlier is to avoid the mistakes, to avoid having products used that you didn't. Communication is just essential, and sharing the specs with everybody is essential. And since Nora's going to be on site throughout this construction project, she's really the GC in a way, but she'll be able to keep an eye on it. And also we have a builder, Brad King, who is top notch and totally on board with this kind of thing, and that helps.
He's one of the best plaster workers I've ever seen.
Miguel said Brad is one of the best plaster workers he's ever seen, and I agree.
We have a question from the chat. Are you using any indoor air quality monitors or tracking any indoor air quality data?
Yes, we plan to. It will probably be something simple like, just something on the market to help people.
Yeah, there are some good ones.
Yeah, there's the one I have at home that I cannot remember the name of it. But there's some good ones that actually have a screen on it, so our occupants or our guests can see, when they cook or when there's a lot of people inside of the cabins that the CO2 goes up. But that will also monitor humidity. But also too, I will be monitoring as the owner. We'll have a couple of spots where we'll be monitoring the moisture within the hempcrete structure. So actually, with some pins to make sure there's no excess moisture in the wood or the lumber framing.
Yeah, moisture meter.
Yeah, a moisture meter with pins. So yes, we are planning to monitor that stuff, and we're really excited about it.
Yeah, it's gonna be fun.
One more.
Yes.
You said on your list, how do you say, a climate appropriate roof. What is your roof system?
So we might make sure we had some good overhang. So it's 2 feet with another 6 inches of gutters.
Mm-hmm.
And then we use, because we're going to be collecting the rainwater, we use metal.
What kind of metal?
We'll use a galvalume. Yeah.
But I thought you were talking about a shade roof or something. Like, what do you do to insulate? How are you stopping the heat flux from the roof, the radiation down into the attic, down into the house?
So we've got an outsulating layer of Gutex with the intelligent membrane on top of it, and then we're filling the joist space with hemp bat. Are we using hemp bat?
Well, yeah. Yeah.
So you're not ventilating it like the shitting around the roof. You're relying all on R values.
Well, we've also got an airspace between It's the roof and
right,
the-
below the metal roof panel, there is a ventilated airspace
How are you creating it?
with diagonally placed sleepers. Yeah, heaters diagonal. Yes, yeah, and
It worked.
yeah, and our builder likes doing it that way. I was recommending a double layer because that's what all the literature that I've looked at from Europe and with these
That's why.
vapor
I
open
developed it,
roofs.
So you didn't have to spend the money.
Yeah.
We've got some updates on that detail if you want.
Oh, great.
Thank you,
Great.
Peter.
Love it. Yes. Are we out of time?
Okay, thank you so much. We really are very grateful to have this great discussion here today. We are at time, but please reach out to our speakers if you have more questions and reach out to us. We will try to get that list of resources out to the email list of anyone who registered for this event. And this recording should also be up on our website in the next week or so. So you will be able to refer to all this great discussion in the future. So thank you again, everyone, for joining us here and on the Zoom. And we appreciate our great speakers and our Design and Health and Wellness Subcommittee for putting this event together for us. So thanks, everyone.